Imagine a darkness so complete, so absolute that even light itself cannot escape. In the far future, humanity's boldest explorers drift between galaxies, cocooned in slumber, trusting their technology to keep them safe. Their ship's AI scans the endless void, vigilant for any sign of danger. For years, nothing disturbs the silence. The universe seems empty, peaceful. The Milky Way is a distant glimmer, a memory fading into the black. Then, without warning, alarms pierce the calm. Something is out there, but the sensors reveal only emptiness, no stars, no debris, nothing at all. The AI frantically checks its systems. The threat is real, but invisible. Something unseen, lurking just beyond perception, exerts a terrifying force. Suddenly the ship is caught in a violent gravitational grip, far stronger than anything it was built to withstand. Metal screams. The hull twists and shatters, torn apart by an invisible hand. In an instant the ship is gone, and drying, sprying, stom. Throughout devoured by a point of infinite darkness. No trace remains, only silence, and the mystery of what claimed it. What could wield such power yet remain unseen? What phantom haunts the cosmic dark? Not a black hole born from a dying star. This is something far more ancient. A primordial black hole, older than the galaxies, forged in the universe's first moments. These ancient wanderers drift through the cosmos, silent and unseen, relics of creation itself. Only now are we beginning to uncover their secrets, and their dangers. Primordial black holes, the universe's hidden predators, waiting in the dark. When you think of a black hole, you picture a giant star's death, a supernova, leaving behind a dense core that warps space and time. These are stellar mass black holes, the familiar monsters of the cosmos, born from the dramatic deaths of stars. But what if a black hole didn't need a star? What if it could form without any fireworks? Imagine a black hole no bigger than a city, a mountain, or even an atom. These are primordial black holes, PBH, not the children of dying stars, but the direct offspring of the Big Bang. Forged in the chaos of the infant universe, they are cosmic fossils from the first second of time. A primordial black hole could have the mass of an asteroid, squeezed into a space smaller than a grain of sand. Completely invisible, revealed only by its gravity. You wouldn't see it coming, only feel its pull, just before it's too late. So, we have two families: stellar black holes, formed from massive stars, and primordial black holes, relics from the dawn of time. Primordial black holes could come in all sizes, from microscopic to colossal. They would be the universe's oldest inhabitants, silent witnesses to cosmic history. Understanding the difference between these two types is key to unlocking the universe's deepest mysteries. From the birth of galaxies to the nature of dark matter, primordial black holes may hold the answers. They challenge everything we thought we knew about black holes. And they might be everywhere. For decades, our story of black holes was simple. Stars live, stars die, and sometimes they leave behind a black hole. Stars are fusion reactors, balancing the outward push of fusion against the inward pull of gravity. When a star runs out of fuel, gravity wins. Smaller stars become white dwarfs, but massive stars collapse catastrophically. The core implodes, triggering a supernova, an explosion that can outshine a galaxy. If the star is massive enough, its core collapses into a singularity, a black hole. The minimum mass for this is about 20 times our sun. For years, this neat story explained the black holes we observed. Big stars die, black holes are born. But then the universe surprised us. We found black holes that were too big and too old to fit this narrative. The cosmos was hiding giants in its closet. Our tidy explanation was about to be challenged. The universe, as always, had more secrets to reveal. The story of black holes was about to get much stranger, and much older. As our telescopes improved, we found monsters at the heart of nearly every large galaxy. Supermassive black holes, millions or billions of times the mass of our sun. Our own galaxy's central black hole, Sagittarius A, is 4 million solar masses, modest compared to others. The problem: how did these giants form so quickly? The first idea was slow growth. Stellar black holes eating gas and stars over billions of years. But there's a limit to how fast a black hole can grow, the Eddington limit. Building a billion solar mass black hole should take longer than the universe has existed. Yet, we found supermassive black holes in the early universe, just a few 100 million years after the Big Bang. It was like finding a full-grown oak tree, a week after planting the acorn. Something was wrong with our theory. The universe was making black holes too big, too fast. We needed a new idea. Enter the James Webb Space Telescope, launched to peer into the universe's infancy. Webb found galaxies that were surprisingly mature, just 300 to 400 million years after the Big Bang. Even more shocking, massive black holes at their centers, far larger than expected for their age. In these early galaxies, black holes made up a significant fraction of the total mass. Unlike in the modern universe, this discovery flipped the old model. Maybe black holes didn't grow inside galaxies. Maybe they came first. What if supermassive black holes were born big, acting as seeds for the first galaxies? If the early universe could create black holes directly, there'd be no size limit. Some density fluctuations could have collapsed into black holes hundreds of thousands of times the mass of our sun. These direct collapse black holes could have seeded the first galaxies. Webb hasn't proven this yet, but its findings point strongly in this direction. The first chapter of cosmic history is being rewritten, and primordial black holes are at the center of the mystery. To understand primordial black holes, we travel back to the first second after the Big Bang. The universe was a hot, dense soup, expanding rapidly, with chaotic fluctuations in density. Most overdense regions simply expanded, but in rare cases, gravity overwhelmed expansion. These patches collapsed directly into black holes. No stars required. This could happen in a fraction of a second, creating black holes of any mass. Some could be as small as a mountain, others as massive as 100,000 stars. Unlike stellar black holes, primordial ones have no minimum size. Their size depends on the conditions in that patch of the early universe. If this theory is correct, billions of these ancient relics could be roaming the cosmos. They formed before the first atoms, before the cosmic microwave background. They are the oldest objects in existence, ghosts from the dawn of time, hiding in plain sight, perfectly black. There was a problem with small primordial black holes. Stephen Hawking's theory of black hole evaporation. Hawking showed that black holes emit faint radiation, losing mass over time. Large black holes evaporate slowly, but small ones vanish quickly. A mountain mass black hole should have evaporated billions of years ago. We've never detected the final bursts of gamma rays from evaporating black holes. For decades, it seemed the universe had swept itself clean of its smallest black holes. But new theories suggest Hawking's calculation might not be the whole story. Some physicists propose that black holes could stop evaporating at a minimum size, a stable, tiny remnant. If true, even the smallest primordial black holes might still exist. The universe's ghost population could be out there given a second chance. One of science's biggest mysteries is dark matter, an invisible substance making up 85% of the universe's matter. For years, physicists searched for exotic particles but found nothing. Now some scientists are reconsidering, what if dark matter is made of primordial black holes? They have mass and gravity, but don't interact with light, perfect dark matter candidates. If true, trillions could be drifting through our galaxy, even passing through our solar system undetected. Most would be small, making them nearly impossible to spot. This idea could solve two cosmic puzzles, the seeds of supermassive black holes, and the identity of dark matter. It's an elegant, compelling solution gaining attention, but it also means the universe is far more dangerous than we imagined. Space exploration would be like sailing through a minefield of invisible traps. We'll need new ways to detect these cosmic ghosts, perhaps by watching how they bend starlight. Discovering primordial black holes would confirm our theories about the Big Bang and dark matter, and remind us the cosmos is still full of hidden dangers, and our journey has only just begun.